Welcome back to Unit 0. This is the last lesson, Quadratics. We're going to learn how to factor and solve quadratics. So first thing about factoring is the very first step of factoring is you factor out the greatest common factor. So that's the very first step. Then there's two methods of factoring. Factor by grouping, which is also called the AC method. That's the way that the high school normally teaches it. And then there's the traditional way, which is just guess and check. One thing you do need to know about a quadratic is the standard form is ax squared plus bx plus c. So let's look at some examples here. So the first one, we're going to factor by grouping, the method we teach at the high school. Very first step always is check the GCF. In this question, the GCF is 1, so we don't actually have to factor it out. Then we identify our a, b, and c. A is 1 because it's the coefficient of x squared. B is negative 11. C is 28. And it's called the AC method because what you do is A times C. So we do 1 times 28. And so we actually have to find the factors of 28. Keep in mind that B is negative, so both of our terms are going to end up being negative because a negative times a negative is a positive. So our factors of 28 are negative 1 and negative 28, negative 2 and negative 14, negative 4 and negative 7. The question what we're looking for is which of these pairs add up to negative 11. And so that's the bottom set, negative 4 and negative 7. So we're actually going to rewrite this trinomial into 4 terms. We're going to keep the first and last term the same. We're actually going to change the negative 11x into negative 4x and negative 7x. So we haven't actually changed anything. What we did was we made more terms just by separating the x's. The reason we do this is we want to group. So we're going to group the first two terms and the last two terms. And we're going to put a plus in between because what we're doing is we're bringing that negative with the 7x. Can't separate them. We now factor out the GCF of both groups. The GCF of x squared minus 4x is x. So we're going to factor out an x. The GCF of negative 7x plus 28 is negative 7. So we always want the first term to be positive. So we factor out a negative 7. That becomes x times the quantity x minus 4, and negative 7 times the quantity x minus 4. The groups should now be the same. If they're not, you messed up somewhere. You need to go back and check your work. Because they're the same, we can now factor out an x minus 4, and that leaves x minus 7. So what this actually becomes is x minus 4 times x minus 7. And this is our final answer. If you need to, you can double distribute. And you should end up with x squared minus 11x plus 28. So all we did was we separated it into a binomial. Right, so that was factor by grouping. And that method works as long as it's factorable. The other method we're going to show you is factor by guess and check. First thing always is to find the GCF. And the GCF here is 5, so we're going to factor out a 5 first. Now, part of guessing and checking is you have to break down your first and last term inside the group. So we're going to start by breaking down the first term, which is 2a squared. Well, we know that a squared is just a times a, so that's how we're going to separate it. There's 1a in one group, 1a in the other group. But the coefficient, we look for the factors of the coefficient. The factors of 2 are 1 and 2. That means that one of the groups will have a 1, one of the groups will have a 2. We don't know about the other term yet, and we're going to work on that for the most part here. We now look at the factors of 18. Keep in mind that b is positive. We only care about the positives in this, and we're going to write a factor chart of our c, which is 18. We now want to just put in our pairs into the groups to figure out which ones would end up back at 2a squared plus 15a plus 18. So we can start by 1 and 18, but realize that 1 and 18 is already bigger than 15, so this doesn't work. We can now try 2 and 9, so if we put 2 in the first blank, 9 in the second blank, we know that 2a will multiply by 9 to get us 18, which is bigger than 15, so we know that doesn't work already. So we can flip-flop those and put 9 in the first blank, 2 in the first blank. Right? 2a times 2 is just 4a. And then 9 times a is 9a. But 4a and 9a don't make 15. They make 13a. So we now know that it's 3 and 6. We just need to know which order they go. So we put 3 in the first blank, 6 in the second blank. 2a times 6a is 12a. 3 times a is 3a. 3a and 12a make 15a, so we know we have it in the correct order. We can go ahead and fill in the 3 and the 6. So that's the guess and check method. You can use whichever method you prefer. It's totally up to you. So now let's look at a special case. This is difference of squares. Notice that 25 and 36 are both perfect squares, and that a squared is a perfect square. There is no b term. In fact, in this question, b is 0. So when we make our factor chart of 36, what we're looking for is when is the pair 0. And that only case is -6 and +6. Okay, so when we do this, we also have to look at the 25, and we know the square root of 25 is 5. So what we're actually doing is we're taking the square root of the first term, the square root of the second term, making one positive and one negative so that the middle term cancels. And that's all a different square is. You just take the square root of the first term, square root of the second term, one's plus, one's negative. So that's a special case. Now let's look at solving. In this question, because there is no b, there's no middle term, you can actually just solve by taking square root. We're going to first subtract by 8 on both sides to get 25. When we take the square root of n squared, we take the square root of 25. Most people mess up here though. Remember that when you take a square root, it's positive and negative. So it's positive and negative 5. This time, however, we have to, since we have a b term, we have to factor by grouping or factor by guess and check. I'm just going to go quickly through this. Our factors of 8, because 1 times 8 is 8. It's 1 and 8, 2 and 4. To get positive 9, it's 1 and 8. So when we factor, we get x plus 8, x plus 1. The whole point of the solving part is because you're doing the exact same method. This time, however, due to the zero product rule, we can set both groups equal to 0 and solve for them, and we'll get our answer. There's going to be 2 answers, just like in the previous one. Right here, we subtract 8 on the left, and we get x equals -8. We subtract 1 on both sides on the right, and we get x is equal to -1. So that's how you solve. After you factor, you just set both groups equal to 0 and solve for x. Sometimes factoring doesn't work. When that happens, use the quadratic formula, which is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So let's see that in action. Here, first thing, you always have to set it equal to 0 first. So we're going to subtract 6 on both sides to get it set equal to 0. Our a is 2, our b is 9, our c is -6. And we're going to fill it into the quadratic formula. So we say -9 plus or minus the square root of 9 squared minus 4 times 2 times -6 all over 2 times 2. And we're just going to simplify this. On the bottom, 2 times 2 is 4. 9 squared is 81. 4 times 2 times 6 is 48. And that becomes positive. We add the inside of the square root. 81 plus 48 becomes 129. And now you can just type it in your calculator. Make sure you do it twice. Once with plus, once with minus. You do -9 plus the square root of 129. Then you divide by 4. And you do -9 minus the square root of 129. And you divide by 4. And you should get 0.589 and -5.089. Okay, so that's a little bit about quadratics, factoring, and solving. Good luck with the practice and application.